When the human genetic code was first mapped back in 2001, everyone said it would transform medicine. Well, finally, that promise has become a reality. And thanks to the 100,000 Genomes project, the NHS will be the first health system in the world to benefit. We went to find out more.
Jessica has a rare genetic condition which causes epilepsy and affects her movement and general development. But which rare disease is it?
She's had MRI scans, she's been under general anaesthetic for that, she's had lumbar puncture, she's had EEGs where they measure her brainwave.
When repeated tests failed to diagnose the rare genetic condition, her parents decided to join the 100,000 Genomes project. It used blood samples from Jessica and her parents to compare their genetic makeup and pinpointed a change in one of Jessica's genes, not present in either of her parents.
We think, looking at this particular gene, that it does explain Jessica's features.
In the past, patients like Jessica with rare genetic conditions would often go on a long journey of discovery to find out what was wrong with them and what treatment would work best. But this trial and error approach was both costly for the NHS and frustrating for the patient. But now genomics, or the study of the human genome, has the capacity to transform the health system as we know it.
Your genome is your body's instruction manual. It's made of DNA. There's a copy in almost every cell. Genomics is the study of the whole genome and all the technologies that you need to analyse and interpret the genome. The 100,000 Genomes project is a landmark project set up by government, and the aim is to sequence 100,000 genomes from around 70,000 people with either rare disease or cancer.
As well as speeding up diagnosis, genomics can also be used to predict how well a person will respond to a particular treatment, so it can be tailored accordingly, what's known as precision medicine. And it's this approach which is set to have a huge impact right across the NHS.
The sheer capacity of the genetic sequencing machines that we have available to us now means that instead of just doing a few thousand bases of DNA, we can actually do tens of millions. And I think part of what this project is aiming to spearhead is a whole change in culture, whereby doctors realise that actually genomics and genetics is going to come into their area of medicine. So we all need to educate ourselves.
It's a pioneering project, which has also put the UK in front.
This is the most exciting project on the planet, because what we're about is transforming the experience of the human race. The UK and the NHS are unique. We not only have the scale in one single coherent system, but we also have the fact that we have alongside that deep science which has accumulated over many years in our hospitals, in our universities, in our science institutes, and particularly the science of genomics. What that means for those within the NHS is they will have better diagnostics, and those diagnostics will link to increasingly improving treatments.
It's already made a big difference to Jessica and her family. They now know that she has GLUT1 deficiency syndrome. This means she doesn't produce enough of the protein, which transports glucose from the blood to the fluid around the brain.
If we'd have, say, had this done when she was born and found out the results straight away, we would have been on the right track immediately rather than having years of diagnostic work done.
And by knowing Jessica's faulty gene was not inherited, it provides peace of mind for her parents. So if they decide to have more children, there's less chance of it being repeated. Jessica and her family are also helping medical research by taking part in the project, by studying her genome and the genomes of families like Jessica's. This project will lead to earlier diagnoses and more tailored treatments being developed for many families just like hers.